We're going to look at the investigation of the effect of inhibitors on enzymes. This practical involves an enzyme and starch solution. You can see the equipment here. The first thing that we have to do is get our water bath ready. So I have that heating ready. And then the next thing we're going to do is we're going to test the solution of starch in a petri dish with a solution to see the colour change. Now generally if you're using starch you always use iodine, so that's your first question there, is what solution do you use? So we'll have iodine and we'll have our starch solution. So I'm actually going to show you what the iodine should look like. As if you put it on white paper you can see it a lot better. And then we're just going to drop a starch and then the iodine solution, and you can see it's a nice bluey purpley colour, right? So that's the first thing we're going to do. Okay, we're on part 3 here now. So what we're going to do is we're going to put 3 grams of starch, or 3 centimetres cubed, sorry, of starch into a test tube. And 1 of the enzyme. And we're going to leave this for 5 minutes. Okay, we've left the starch and the enzyme for 5 minutes, and we're going to do the same thing in the petri dish. Just a couple of drops of that. Drop the iodine. And you can see it's a brown colour. Okay? So what has happened here is the enzyme has broken down the starch into glucose. So glucose does not go a black colour. Okay, it's just the starch will go a black, bluey, purpley colour. If there's only glucose there, it will remain a brownish colour. It is quite brown, it is quite dark, but it's not a black colour. Okay, so anyway, I've already compared the results here. So we had to do a table just to compare the colour change there. And that's the stage and method. That's your starch and iodine, which is a black or bluey black colour, and your starch, amylase and iodine is a brown colour. Okay? So the next part, what we're going to do now is we're going to put Benedict's into this test tube here, and then we're going to heat it. So with 4 mils of the Benedict's. You see it's a nice blue colour. And then we're going to heat it and look for some sort of a colour change. Now, I'm sure that you know that the Benedict's is testing for glucose, and if it's positive, if there's glucose in here, then it's going to go a nice green colour, or if there's a lot in it, it's going to go red. But bear in mind that Benedict's is actually an inhibitor, right? So we're just going to keep filling this for 180 seconds, and we just write more than 180 seconds because we don't want to be standing here for Oh, here we go. So that's 1 minute and 15 seconds. So that's 75 seconds. So we write this in here, 75 seconds. Okay. So you can see the colour change there. So there's obviously some glucose in the solution itself, right? And then the next part of the, so I've put 75 seconds there. The next part is that there's a hypothesis here that lowering the concentration starch below 1% will have no effect on the rate at which the product is produced. Okay, so what we need to do then is we're going to make up serial dilutions. Okay, stop. Right, so the next part of the practical, what we have to do is we have to make up serial dilutions. Okay, so 5 different beakers labelled, and what we need to do is we're going to take 10 of the 1 molar solution. I should do it here. We need to start off with 20 actually. The first step is we take 20 ml of the starch solution. And you can either use a syringe or a conical flask. Right, today I'm going to use a syringe because it's quicker. Right, and set this aside because we don't need this now, so you don't get mixed up. You take 10 ml of this and you put it into the next beaker which you've labelled, and then 10 of water, and that will bring your concentrations down to 0.5%. And then you take 10 from here into here. Make sure you keep your syringes separate so you don't get mixed up. Another 10. And what I generally do is I take 10 out and throw it out, because then each beaker then has 10 ml in it. Okay? Stop. Right, now what I need to do is I am going to start off with the lowest concentration, which is 0.0625. I'm going to take 3 ml of the starch, put it into the test tube which I've labelled. 3 ml into each of these test tubes at various different concentrations. Then I'm going to put 1 ml of the enzyme, and then I'm going to leave it for 5 minutes. Okay, so I take 3. Rinse this in the water a little bit. Okay, and you just put 3 in each of these. Okay. Okay, so I've transferred all the starch into the test tubes now, and what I want to do now is put 1 ml of the enzyme into each of these. So we'll just do the first one. Okay, stop. Right, so we have the starch with the enzyme. We've left it for 5 minutes, and what we're going to do one at a time, I'm going to put 4 ml of Benedict's into the test tube. I'm going to heat it in the water bath and time and wait for the colour change. So we'll do the first one. We'll do the lowest one first. So again, we're looking for a colour change. All the different concentrations of the starch, and you can see it's got a green colour. If there was a lot of sugar in it, glucose in it, then it would go like a brick red colour, but obviously the enzyme, which would be amylase, has broken some of the starch into glucose itself. You can see the times here. So basically, the students said that lower the concentration of starch below 1% will have no effect on the rate at which the product is produced. Well, obviously it does. You can see here the 1% starch only took 69 seconds, and the one here, generally we stop the stopwatch after 180 seconds, but for the purposes of this practical I just kept it going. It took an awful long time. So these ones here, and sometimes this one actually won't even turn green colour at all, but these ones here were fairly quick, and that was our first result there as well, so they're fairly similar. Okay, thank you.